Okay, moving on to C. Okay, in C, we add 0.04 grams of sodium hydroxide. So from this, we know that we are adding OH minus to the buffer. Alright, and given the information, we will be able to find the number of moles of NaOH using the mass and the MR of sodium hydroxide. Okay, there are two parts to this question. Number one, to calculate the change in the pH, and number two, the qualitative effect on the concentrations of the buffer solid pair. Okay, so there are two parts to this question. Alright, qualitative effect meaning there's no calculations required. So we'll tackle part 2 first because it's easier. So again, in the buffer recap, we have weak acid and its conjugate base. Okay, in this case, we are adding in OH minus. Okay, which is the species that will react with the OH minus. It will be your weak acid. Okay, your weak acid will be the one reacting with OH minus. So take a look. Okay, this is a concept that we discussed in A earlier on. So the citric acid will remove the added OH minus. So what's the effect on the concentration? The acid concentration will decrease while your conjugate base concentration will increase. Okay, so you can see this is formed. Alright, so as a result, the concentration will increase, and while this, for the weak acid, will decrease. Okay, so that answers your part 2. Okay, to calculate the change in pH, we have to be systematic. First of all, find the number of moles of NaOH added. So 0.04 divided by 40, you get this number of moles. How do you get this 40? It basically is the MR of NaOH, right? You have 23.0 plus 16.0 for oxygen and plus 1.0 for your hydrogen. Okay, so since from the equation, NaOH is a 1:1 ratio of hydroxide, the amount of hydroxide added in will be the same amount of moles of NaOH. Okay, so this is the amount of NaOH or OH minus we added in. So let's take a look at the initial. So for 1 dm cube, initially we have 0.06 moles of your acid and 0.120 moles of your conjugate base. Right? Where do you get this information from? Because the context early on says that, right, we have this concentration of acid and this concentration of conjugate base. So color coding for ease of reference are, with acid we have this number of moles, conjugate base we have this number of moles. Okay, and how do I know is this number of moles given at this concentration? Because the question says that we assume 1 dm cube of the solution. So the concentration will be just multiplied by 1, alright, to get the number of moles. Okay, since the OH minus added in 0.00100 mole, so these two will react. Okay, so what happens? You have a decrease of acid. The OH minus will be reacted away, removed away, and as a result, based on the mole ratio 1:1:1, you will produce 0.001 more moles of conjugate base. Alright. Okay, so this is how you get the values. So once you have that, given that we added in 0.04 grams of sodium hydroxide, we have to assume that this is going to be solid. We assume that any change in the volume is negligible, right? Because we're not adding a solution, we're adding a solid. So there's no significant change in the volume of the buffer solution. The volume of the buffer solution will still be 1 dm cube. So the new concentration will be just equivalent to the final moles, right? The final moles of the species. Right, the one I'm boxing out now in red, this one, and this one. This number of moles divided by 1 dm cube, this number of moles divided by 1 dm cube. So we have the new acid concentration as well as the new salt concentration for the buffer. So once you have that, which you can find the new pH, substituting the new concentrations into it. Okay, apply your acid buffer equation, which is your pKa plus log salt over acid. Okay, find out a new pH, so 3.44. Okay, so if you compare this with your earlier calculation in B, your original pH is 3.43. In C, the new pH is now 3.44. What's the change in pH then? So change in pH will be the final pH minus the initial pH. So 3.44 minus 3.43, it's a 0.01 increase. Okay, so that sums out question 4C. Okay, if not, if you're alright with this, we will move on to an additional question which is not featured in the tutorial question paper. Maybe I'll just scroll down to the question. You can take note of the question and try to do the question. Try to attempt to do this question to see if you can apply the concept you learned in 4C into a new context. Okay, so for this is the new question that you have to extend your understanding. Okay, take note, we are supposed to calculate the change in pH when 0.002 moles of a strong dibasic acid is added to 1 dm³ of the buffer solution prepared in B. Okay, so you can take note of this question. Try this before you look at the next video.